Alrighty, so the last section, the last method of finding volume is what's called cross sections. Okay, cross sections. So cross sections, if you were to cut into a solid object, let's see, I don't think I have a solid object, but if you were to cut into a solid object, a shape would form, right? A shape would form. So let's see, even though this is not a solid object, let's pretend it was a brick. Let's pretend it was a brick made of paper or cardboard, something. So if I was to slice right through it, slice all the way through it and make two pieces, it would still be 3D, right? But the cross section would be the 2D shape it made. So if I was to cut through this and show you the end, what shape would it be? What shape would it be if I were to cut through this rectangular prism? It's a rectangular prism. If I were to cut through it, slice through it like that, and then I were to have two pieces and show you like this, what shape would you see? You would see this shape, right? Which is like a rectangle, right? A rectangle. So we would say that this shape, this solid brick, has a rectangle for a cross section. Okay, that's what we mean by cross sections. If you were to cut it, what shape would form? And so I put three shapes on here that these are the types of things we're going to be finding volume of. Okay, so the first thing, it's kind of like a loaf of bread kind of thing, right? They cut up slices. Each of those slices has what shape for a cross section? What shape is a cross section? Each of those. So if I was to cut this slice in half, or cut it at the end, or cut it anywhere, what shape would be the cross section? Half circle, semicircle, yeah. Okay. So that's that cross section would be a semicircle. This shape here, okay, it's kind of a cone. Okay. If I was to cut this way down, straight down, it would have a triangle, right? It would have triangles. It would have a cross section of triangles. This shape here, similar to the first one I showed you, but different. If I were to cut in the middle of them, they would be rectangles again. Okay, even though it's got kind of like rounded, it's still a rectangle. Okay, so these are the types of shapes we're going to be finding volume of today. They're different than the ones we've been finding. Does anyone know what the difference is? What's different about these shapes, the way they look, versus the ones we've been doing with washer method and disc method? Just by appearance, what's the difference? There's one quick difference. You can always tell by these things. Two words. Flat bottom. They always have flat bottoms. Flat bottoms. The other ones did not have flat bottoms. The other ones did not. If you look at those, I'm not going to take time to look at those, but if you did, some were donuts, some were cones, some were cups. They didn't have flat bottoms. These guys always have flat bottoms because they don't go into, you see, they just exist on the surface. They don't go deep in, right? There's no rotations. There's no solid revolutions here, okay? There's nothing like that. These are made consistent. These are already made. They're shapes that already exist. They're not like revolving around the x-axis, revolving around y=2. That's not what we're dealing with these guys today. Okay. Cross section. So how do we find volume of these? Well, since there are no revolutions, we don't have a pi. The reason we had pi before was because of the circle we made with the revolution, right? We made a circle revolution. We don't do that today, so there's no pi. Okay. So our biggest thing is we need to find the area of one of those guys. So area of one of those semicircles, area of one of those triangles, area of one of those rectangles. Once we find area of one of them, we're done. We plug it in, find the bounds, okay? dy over dx is really easy to tell. They'll tell you if it's perpendicular, if they say each of these, like see these little guys here, these half circles here, are these perpendicular, these half circles here, each of these half circles, are they perpendicular to the x or are they perpendicular to the y? Each of those little slices of half circle. Are they perpendicular to x or are they perpendicular to y? So perpendicular means they cross at 90 degrees. Parallel means going the same way. So this one, these are going the same way as y, right? So if they're parallel to y, they're perpendicular to x, perpendicular. So if we were solving this problem here, it would be a dx, okay? It would be a dx problem. If the slices were running the other way, if the slices were going the other way, then it would be a dy problem, okay? And they'll tell you if it's perpendicular to x or y, and they'll tell you if it's parallel to x or y. So from there, you decide whether it's dy or dx, okay? Okay, so these are the shapes we're trying to create. All right, okay, so the first one. Okay, the first problem. Find the volume of the solid if the base is bounded by y equals square root x equals 9, and the x-axis. Bases of cross sections are perpendicular to the x-axis. So it says volume, but nowhere does it say revolve around, right? It does not say revolve around. In its place, it has this word cross sections. That's how you know it's going to be a cross sections problem, right? It's not going to revolve around anything, okay? So they're pretty easy to tell which one's which. Which one is which? Do I do a washer method, disk method, or cross sections? Well, this one you can only do cross sections because it's not revolving. Okay, so the first thing I'm going to do is like I did before, draw the thing. Okay, draw the graph, see what's going on. So we have 3 functions on a graph. Okay, we have the x-axis. All right, the x-axis. Y equals 0. We have x equals 9. Okay, x equals, it's not going to be the scale, but at least it'll give me a picture. X equals 9. Okay. And then y equals square root of x. Okay. Well, y equals square root of x means y is always going to be the square root of x. So if I plug in numbers for x, find the square root, it gives me my y. So if I plug in 1, I get 1, 1. If I plug in 4, I get 2, and so on and so forth. The square root looks like that. It's increasing, but very, 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 very slowly. Okay. So the area is bounded. Well, the only area bounded is right here. That's the area we're talking about. Okay. That part, that green part, is not revolving around anything. It's not revolving. Squares are going to go on top of it. Squares are going to go on top of it. So they have little slices of squares like this, like I'm showing you right now. Little slices of squares. Those are going to, let me make this a little bigger so we can see. Little slices of squares are going to be stacked here and here and here. An infinite number of slices are going to be there. Some are going to be thinner than others or not as wide as others, but that's what it's going to look like. So it's going to have like a shape like this. They're all going to come up. It's a square. What do we know about squares? What do you know? Yeah, just what do you know about squares? What is your background? What is your prior knowledge on squares? They have a length and width. Definitely. What else? No one knows anything. Yes, Roman. There you go. Yeah. In fact, the length and width is equal to each other. It has four sides. They're all the same, 490-degree angles, right? Okay. So if you look at the formula, we're going to have to find area of one of those squares. Okay. So we need to find area. Okay. So this is what it looks like, right? Okay. So let's set up what we need. So we need volume equals A to B, area of one of them, area of one of those squares. And this is this going to be a dx or dy problem? Dx or dy problem? The dx or dy problem? Dx. It's going to be a dx, perpendicular to the x-axis. Okay. Okay, so we need bounds, and we need to find area. Okay, so let's do bounds. So if it's dx, where am I looking for bounds? Top, bottom, left, or right? So if it's dx, am I looking side to side, or am I looking top and bottom for bounds? Left and right? Left and right of the green stuff, right? So the left edge of the green is 0, because the square root of 0 is 0. Okay, so from 0. The right edge is going to be the blue line. It doesn't go past the blue line. That's the fence on the right side. So 9. So 0 to 9. Okay, done with that. So now I have to find area of one of those squares. One of those squares that is going to be sitting on top. The squares, each of the squares is going to be looking like this. It's going to have one edge here, and it's going to go straight down and have another edge there. The width is going to change, right? The width is going to change. If a square is here, it's going to have a width there. But if a square is in the back, it's going to have a very small width. Or if it's close to this edge here, it's going to have a larger width, right? The width is going to change. So I can't just say the width is 10, or the width is 9, or the width is 2, right? It's going to change. It's fluid for each square that sits on top of there, right? Because this guy is going to kind of look like this picture here if each of these were squares. So kind of picture in your head, instead of half circles, semicircles, squares. Okay, it's going to look very similar to this guy here. Okay, so you can kind of see it goes up. Instead of rounding out, it's just going to go up and come over. Right, that kind of thing. Okay, but it's going to kind of taper off. You can see how it's going to taper off when it gets to 0, because the squares are going to become smaller. Right, the squares are going to become smaller. In the front, the squares are wide. They have a width of whatever, height is the same, or length or whatever. And down here, the squares are going to become very, very small. Okay. Okay, so now we need to find area. Well, we know area of a square. We just said area of a square. Area of a square is side squared, right? You find one side, you square it, you got your area of a square. So we just need to find one side. So my question is, how can I find area of one side? We know the sides are going to be different, so it's not going to be a number. It's going to be a function that's going to help me. So if I wanted to calculate area of one side of the squares, How would I do that? Right? Because it's going to have a lot of these guys. It's going to have this. Each square is going to go edge to edge. That's going to determine the side length, right? And it's all going to be different because the function is a curve. The function is not a line. Yeah. So yeah. So to determine this length here, we're going to have to figure out the y value at the top minus the y value at the bottom. That'll give me length, right? The y value at the top minus the y value at the bottom. Okay. So to get the y value, how would I get the y value here? Like specifically for this guy, if I wanted to find the y value for this guy right here, what would I need to do? Plug into the function, right? Plug it into the function. So the function is y equals square root x. I would plug in x, whatever x is here, and get a y, right? So to figure out the side, so side is going to be square root x, and then I'm going to subtract it from the y value down here. How do I determine the y value down here? Well, what is the y value down here always going to be for this guy here? Or how do I determine the y value down there? It's going to always be y equals 0 because that's the x-axis, right? So we're going to subtract it from 0. That's the side length of one of them. In fact, you can simplify that and just say square root x. So one side length is the square root of x. So if I want to find area, I'm going to square that. Okay? Square root of x squared is just x. So the area of one of those squares is just x. So now I'm going to take that guy over here and put that right there. Okay. For today, I'm not going to go into solving because you guys can do that. You guys can actually figure it out the volume on your own. You don't need me to do that because you guys have had, I think, 2 tests already on that. I'm just going to help you set it up. Okay. I'm going to help you set it up on how to do that. Okay. If you don't remember how to antiderivative and do that, look at your past notes or come talk to me or something, but I'll help you out. But it's just we don't have time to go into every problem, especially when you guys have done that a million times. Okay. So let's go to the next one. Let's go to the next one. Same example. Now we got semicircles. Okay. So it's the same graph. Now instead of squares, we have semicircles. Okay. So what's the area of a semicircle? What's the area of a semicircle? It's so the area of a square of a circle of a whole circle. It's pi r squared, right? Pi r squared. And a semicircle is just half of that. So you can divide that by 2, or you can just say half of it. Either one is okay. Okay. So the semicircles are going to be from here to here. So this one's going to look exactly like this guy here. It's going to look exactly like that, 100%. that shape is going to look like this. Okay, so what I have to do is find out this length here. Well, we already know that length. Don't I know this length here? What is this length going to be? We got a lot of stuff to cover, guys. I need your help. Come on. What is this length going to be? Yeah, square root of x, right? We have a test on Thursday and Friday, right? And we still haven't reviewed yet. Okay, so if we don't finish this today, we got to finish it tomorrow, which means your review time gets shrunken by a lot. So let's finish this. Okay, so the square root of x. So I know that this length here is the square root of x because we just figured that out on the last problem. What does that represent for a semicircle? What does that represent for a semicircle? What does this length represent? Not the radius. Doesn't represent the radius. What does it represent? The diameter. It represents the whole way across, right? The diameter is square root of 2. Square root of x, right? Well, I don't need the diameter, but the diameter and the radius have a relationship. What relationship do the diameter and the radius have? What relationship do the diameter and the radius have? Yeah. Exactly. Radius is half. So this is going to be square root over x divided by 2, or 1/2 the square root of x, whatever you want to say. Well, there you go. I got the rest. So it'll be 1/2 pi times the square root of x divided by 2 squared. That'll give me area of one cross section. Okay, so we got 1/2 pi x over 4 times x over 4, which when I simplify that, I get pi x over 8. Okay, that's the area of one cross section of one of those. So once I have that, the rest is the same. 0 to 9 still. Still dx because it's perpendicular to the x-axis. Okay. From there, you guys can do the rest. If it's a calculator, easy. Just plug it into the calculator. If it's a non-calculator question, you have to find the antiderivative, and then plug in 9, plug in 0, subtract them. You guys have done that lots and lots and lots of times. Okay, so I'm going to go on to the next part. Okay, so it's the same thing, different shape. Okay. Square root x, x equals 9, x-axis, perpendicular to the x-axis. So it's going to be dx, right? We know volume equals, it's going to be the same bounds. Same thing here. We know it's going to be dx. Now the shape is different. The shape is an isosceles right triangle with one of the bases, with the base as the leg of the triangle. Isosceles triangles. Isosceles triangles, 2 of the sides are equal. The third side is not. Okay, so that's what an isosceles triangle is. So an isosceles triangle. So this is how it's gonna look. It says the leg. The legs are the 2 shorter sides. The leg is gonna be, so it's gonna look like this, or look like this. It doesn't say, but it's the same thing. Okay, so each of these are gonna be sticking out. So this guy right here represents one of its legs. Okay, represents one of its legs. So how do I find area of a triangle? How do I find area of a triangle? So yeah, base times height or side squared divided by 2. So base times height divided by 2 or side squared divided by 2, either one, or 1/2 base times height, either one of those works. Doesn't matter which one you use. Okay, so if I have a triangle that looks like this, right? If I have a triangle, isosceles triangle means 2 of the sides are exactly the same. It's a right triangle, they told us. This side right here is going to be from here to here. So we already know that side, right? We already know that side. It's the square root of x. Okay, so we know one of them. Let's call that the base. How do I find the other one? How do I find the height? Since it's an isosceles triangle, it's exactly the same. It's exactly the same. Okay, so we have area equals square root of x times the square root of x divided by 2. So we have area equals square root of x times the square root of x is the square root of x squared, or just x, over 2. Okay, put that guy in here. You can do the rest, okay, to figure out the volume. Like I said, if it's a calculator, plug it in. If it's not, just find the antiderivative, which would be x squared over 4, 1/4 x squared, and then plug in 9, plug in 0, you got your answer. Okay. All right, so now let's change it up a little bit. Let's change it up. So now, example number 2, we have different functions now, different functions. So the first thing I'm going to do is I'm going to draw those functions out. I'm going to see what picture they have. They didn't give us a picture, so I need a picture. Y equals x squared is just a parabola, just your basic parabola. Nothing, it's not shifted at all. Doesn't go up, doesn't go down, doesn't go left, doesn't go right. Its origin is at 0, 0. So our vertex is at 0, 0. It looks just like that. Okay. So the bounded part is inside the parabola, up to 9. Okay. So we know the bounded part. So it says the first one, cross sections are perpendicular to y. So we have squares this time. So each square is going to be perpendicular to y. Means they're going to go this way. Each square is. So if it's perpendicular to y, that means it's a dy problem, right? It's a dy problem. Okay. Dy. Okay. So each one of those squares, we already know the area of a square, right? We did it before. Area of a square is side squared. Each one of those squares is going to be going from here to here. Side to side. all the way across, all the way across, right? Square standing straight up. Okay. So we have to figure out the side length of one of them. So how do I determine the side length from here to here? How am I going to determine how long it is or how far it is from here to here? That's going to help me find area. It's going to change. It's not always going to be the same because parabolas have curves. Parabolas widen as they get tall, as they get higher, as y get higher, they widen. So it's not going to be like a whole number. Like I said, it's going to have to be a way. Well, the way to do this, it's actually easier than you think. How do I find one dot? How do I find the other dot? How do I find the distance between the two values? I'm not looking for y values here, right? I'm looking for x values. I'm looking for x. Where is this x? Where is this x? And I'm going to subtract them, right? That's how you find length. You find out where it is and you subtract them, where each of them are. So how do I find the first y value? Or the x value? How do I find that guy there? Mm-hmm. Say again. Square root of y. I don't see a square root of y anywhere. I'm not saying it's wrong, but I'm just saying, how do you do it? Don't give me the answer. I don't want the answer. I want to know how to do it. Because I have one person talking, so I'm under the assumption that no one knows how to do this. Okay, if I'm wrong, please tell me I'm wrong. But I'm under the assumption that no one knows. I have 19 people that have no idea what they're doing. Okay, so I want to help you get there. So don't give me answers. Tell me how to get there. Okay, if you know what to do, please tell me. Please tell me. Don't just sit there and be quiet. Okay. Mhm. Take the equation, solve it for y. Let's do that first. Okay, that's a step. So let's do that. So, so which equation? Which equation were you talking about? There we go. Okay, so let's take y equals x squared. Y equals x squared. And solve it for x. Okay, we can do that. Take the square root. It'll be plus or minus, right? Why was that necessary? You're right, Justin. That was absolutely necessary. Why was that necessary? Why was that step you just said necessary? It is. Absolutely. We had to do it. Why? Why do we have to do that? Can, there you go, right? We're using dy, right? Dy means no more y equals. We need x equals, right? That's why we needed to do that. Good. Okay. Now, how can I use this guy to figure out where this point is here? How can I use this guy here that I just found to find out where that point is there? The answer is it's going to change, right? It just depends on where it is. If it's up here, the y value is up here. If it's down here, what this says is if you give me a y, I can give you an x. If you tell me, if you know what y is going to be, I can tell you what x is going to be. And isn't that what we need? I need to find an x, right? I need to find out what x is over here. Because if I find what x is over here and what x is over there, I can subtract them, okay? And there you go. That's the distance. That's a side, right? I don't know what y is. So instead of plugging in numbers, like I said before, you're not going to get clean answers. I have to use this function here. I'm going to use this function here. Or it's not a function, but I'm going to use this equation here. This is what I would use to find the x value of this guy and the x value of this guy. Okay? Okay? What's true about this side over here, though? What's going to be negative? Only x, right? Over here, x is always going to be negative, right? Because it's the left side of the x-axis, or the y-axis, sorry. Over here, x is always going to be positive, right? So why is it plus or minus? Because I have to use the negative over here, and I have to use the positive over here. Okay, if I'm trying to find the x, x is always going to be negative over here. X is always going to be positive over here. Okay, so how do I find side length? Subtract them. Yeah, subtract them, right? Subtract. So one side length is going to be square root of y minus negative square root of y. That'll give me that side length. Put them together, you get 2 square root of y. Oops, no, I don't want. That's a side length. To get area, I have to square them. And you're going to get 4y. Because you square 2, you get 4. You square y, square root of y, you get y. That's the area here. That's what I'm going to put over here. Okay. Now bounds. So when I go for bounds, I look at the green stuff. Green stuff tells me the bounds, but it's dy. So I'm not looking left and right. I'm not looking left and right. I'm not saying this guy to this guy here. I'm looking bottom to top. Well, the bottom is 0. The top is 9. Done. Find the antiderivative. Be 4y squared divided by 2. Plug in 9. Plug in 0. Subtract them. Boom, you're done. Okay. All right. Let's try this one now. Let's get at least one more done. At least one more done. If we can get 2, great. If not, we got enough. Okay, so then the second to last one you have on yours is the same. Except it's semicircles now. Okay. Semicircles. Everything else is the same. Everything else is exactly the same. It's still perpendicular to the y, so it's still going to be dy. Okay. So each of the semicircles, edge to edge, is going to be going right on top of the pink line. So they're going to be stacked like that. Okay. So pink dot to pink dot is going to be the diameter. Is going to be the diameter all the way across, right? We know the distance from pink dot to pink dot. We just did that on the last one. On the last problem, we had diameter was 2 square root y, right? We said the distance from pink dot to pink dot was 2 root y, okay? In this case, since it's a different shape, it's a diameter. Radius is half of that, okay? Radius is half of that. So radius only goes from one pink dot to the middle, which is half. So if I divide it by 2, I'm going to get the square root of y. Okay, I'm going to get the square root of y. That's what the radius is, just the square root of y. Okay. So now I'm going to go plug it in to my area. Area is 1/2 pi times the square root of y squared, since that's the radius. The square root of y squared is just y. So it's going to be 1/2 pi times y, which is the same thing as pi times y over 2. That's my area. Okay. Bounds are from 0 to 9. Still 0 to 9 because the bottom is still 0. Bottom of the green stuff is still 0. Top of the green stuff is still 9. Okay. All right, we got time for one more. I want you to do number 3 on your own. I want you to do number 3. Should be the last one on your page, back page. I want you to do this one on your own. I'll give you about 5-7 minutes-ish. Okay. Picture's already drawn from you, so you don't have to draw a picture. Okay, so I set it up. This line here is y equals x. This line here is y equals negative x. They're just lines, okay? They're perpendicular to each other. This is x equals 4, okay? So the orange stuff is the bounded area, okay? We have perpendicular to x, so that's dx. Each of the squares is going to be perpendicular to x, okay? Okay, so the blue line I drew, the blue line with the dots, is going to be the length of one of the sides of the squares. It's going to be the length of one of the sides of the squares. So we have to figure out the length, except it's going to change. Over here, the length is going to be really short. Over here, the length is going to be really long, right? It's fluid. The length of each side is fluid. It changes. So instead of giving me numbers, we have to give functions. So if I wanted to find the height here, not height, the y value here and the y value here, how would I do that? I would use these guys here, right? I would plug in my x and solve for y, right? One of them would be a positive number, one of them would be a negative number, okay? So to calculate this, I would take this guy and subtract it from that guy, okay? So a side length is going to be x minus negative x, which is 2x. So one side length is going to be 2x. Well, that means area is going to be 4x squared. Okay, area would just be that side squared. Okay, that's the first thing. The second thing, bounds. Well, it's dx. So dx's bounds go from left side of the orange stuff to the right side of the orange stuff. So right here to right here. That's 0 to 4. Okay. Done. The rest of it, if this question was on your has been on your last test, you guys would have said this is easy. This one is really easy, right? That's the nice thing about these guys. They don't have the hard part is getting here. Once you get there, the rest is really easy because you guys have done that a million times and harder, much harder stuff, right? So it would be, let's see, 4x cubed divided by 3. And then we have to plug in 0, plug in 4, subtract them. So you would get 4 cubed over 3 minus 0 cubed over 3. Well, luckily the 0 stuff, anything times 0 is just 0. So that's going to go away. So 4 to the third power is 64. 64 times 4 is 256 over 3. Which, does it go in? No. So we'll leave it like that. Okay. All right. So the key here, last 3 minutes, the key here for each of these guys is picture. Once you have your picture, am I perpendicular to X, perpendicular to Y? Where am I doing that? And then go side to side. Okay. I'm only going to give you semicircles and semicircles, isosceles triangle like we did here, and squares. That's the only shapes I'm going to give you. I'm not going to give you any crazy shape that you've never seen. Okay. One of those 3 shapes I'm going to give you on any problems. Okay. So isosceles triangle, semicircle, or a square. Okay. I'm not even going to give you a rectangle, right? Rectangles are the same as squares, except the height is not the same as the base, but I'm not going to give you that. Okay. I'm only going to give you ones like this. Okay. So the assignment, I'm going to post an assignment today. It's going to be on paper. It won't be on Delta Math. It's not going to be very long. Okay. It's going to be like 2 or 3 problems. That's it. I just want you guys to practice this on your own. Okay. Practice this on your own. Tomorrow, when you come in, we're going to do a full review. It's not a big chapter. We did 2 things: area between the curves and volume. That's all we did, right? It was 4 lessons. So it wasn't a big chapter. So the review is not going to be very long. 5, 6 questions tops. Okay. So tomorrow when you come in, that's all we're going to be doing. Okay. Because it wasn't a big chapter. All right. Okay. All right.